you can see that in this question we have seen that the blocks will not move, and there is a tension we have got, that the tension lies in between a range. If you remember this question, do you remember that particular question? Yes, and we have done one more question regarding that, where yes, where we have got a range of the tension. Now, when I was studying that thing, and I researched more, then I found that that tension can be a particular value, right? Although the value will lie in between that range, but actually we can find a particular value of the tension. Let me first share you a very simple case of this particular situation, right? So before proceeding further, we'll try to discuss that in details. Let us try to assume that a very simple case where this 10 kg block is placed over that floor, and there is a friction in between the block and the floor which is 0.6. The block cannot move because that block is tied with a wall with a string, and I am applying a 50 Newton force on that block. So now if I ask you what is the tension in that string, what should be your answer?
0 Newton.
0 Newton, right? Although if you draw the free body diagram of this block, then we can find a mathematical expression for the tension, right? You can see what is the mathematical expression for the tension. If this is the block, this is 50 Newton, right, and this is the tension force, and I can say that here the friction force will act. So my equation will become T plus F equal to 50. So F is equal to 50 minus T, and that should be less than or equal to mu into N, which is equal to 60 here, right? So what is the value of tension? You can find that the value of tension is greater than or equal to minus 10. So basically any value of tension which is greater than minus 10 will satisfy this condition. For example, if you take the value of tension to be 10 Newton, then also it satisfies because tension is 10 Newton, friction is 30 Newton. That is also possible, right? But do I take that tension to be 10 Newton as my answer?
No, sir.
No, I will not take tension to be 10 Newton as my answer. I will take tension to be 0 Newton in this particular case. So what is the reason behind that? The reason is very simple, that whenever tension and friction both are there and both opposing this applied force, then which one is appearing first, the tension or the friction first? Friction, yes. Friction appears first, and after that tension will come into play, and tension will increase its value from 0. It's not that tension will suddenly have a particular value and then it will increase. So tension will increase its particular value from 0. So suppose if I say that at tension equal to 0 Newton this entire condition is satisfied, so why the tension will increase further? Because at t equal to 0 Newton, the entire condition is satisfied. So there is no need that I can say that tension is 2 Newton or tension is 10 Newton, right? So in this type of questions, always take the minimum value of tension which satisfies the condition. Have you understood the logic behind that? Because tension will start from 0, and if so at some particular point if it satisfies all the condition that are given in your question, then why I will again extend the tension should be greater than that. So I think that the range we have got, we will take always the minimum value of that range to be the tension in that particular case. Understood? So that is why we can find a particular case. I have also written this situation here, that first friction will act and then tension will come when both opposes the applied force. So we will take the minimum value of tension that satisfies the condition of motion. Right? We will take the minimum value of tension that satisfies the conditions of motion. That you need to remember. And then we can solve few more questions regarding the same concept. Can you just try to solve this particular one?
Sir.
Yes. Go.
Sir, there was a question regarding this tension in the last class that.
Yes, I think the answer of that question will also be the minimum value, which is 40 by 3.
Yes.
Yes.
But then D will be correct.
Yes. We'll come to that question also. First, try to solve this one. Although a very simple one, but try that.
Sir, 0.
Yes. How can I say that it is 60 Newton?
If we draw the FBD, then
60 Newton.
Yes. First of all, we need to check whether the bodies will move or not. Will the body move or not? Because the net force is 20 Newton and the net friction force, I think that the limiting friction here for block A and this
20.
is block B. Limiting friction for block A is 20 Newton and limiting friction for block B is equal to 60 Newton. So the limiting friction is 80 Newton, that cannot be overcome by that 20 Newton force. So as they cannot move, so the direction of friction is anything, because this is a static in nature. So if I apply the 100 Newton force here and the tension is in this direction, so in order to make the tension minimum, in which direction I will always assume that friction force for that block B? In its own direction, right? Yes, in the direction of tension. So I can say that T plus Fb is equal to 100. That is the condition that tension needs to satisfy here. And in that case, I can say that Fb is equal to 100 minus T, which has a maximum value of 60 Newton. So I can say that T should be greater than or equal to 40 Newton in this case. But if T is 40 Newton, you will see that then the condition for no motion for block A will not be satisfied, right? So let us first calculate what is the condition of no motion for the block A, and what is the minimum value of tension needed in that particular case. Again,
so we have to take the intersection of the two cases and then take the least value.
Yes, because both the conditions have to be satisfied. So T plus Fa here in this case, T plus Fa is equal to 80 Newton. One second. T plus Fa is equal to 80 Newton, and we can find the value of T from this equation, that Fa is equal to 80 minus T, that is less than or equal to 20 here. So the value of T should be greater than or equal to 60. So what should be the value of tension that satisfies both the condition? 60 Newton. So definitely that should be the answer of this question. Right? Okay.
Sir,
Yes.
so we could also do like this, that T plus Fb minus T minus Fa is equal to 20. Then
What
Fb minus Fa is equal to 20.
T plus Fb?
Sir, the first equation minus the second equation.
Yes, in that case, but in first equation, Fa and Fb, they are actually not known. Can you
Sir, F
minus FB equals to 20. FB minus FB equals to 20.
Yes, sir. Then Fa is the maximum value of Fa is 20. So
yes, in that case also you can find. But you have to find the value of tension. That is why I got the value of tension here directly. Right? You can always use this method. Now can you solve this particular question? Same similar type of question. I have just reversed the direction of 80 Newton force. Can you see? On the block A, I have just reversed the direction of 80 Newton force.
So 10 Newton in the opposite direction.
Sir, 10 Newton.
Is it 10
Opposite
Newton?
direction. Yes, sir.
Yes, sir.
Sure. It may be. One second.
0 Newton.
I don't think it's 10 Newton. One second.
0 Newton.
Yes. I think
0
the
Newton.
answer should
Yeah,
be
it
0
cannot be
Newton.
in the opposite direction. It will be 0 Newton.
Yes. The answer should
Yes.
be 0 Newton.
So tension cannot be negative. So
Yes.
it will be-
Tension cannot come in the opposite direction.
Yes. Look, whenever you are doing this type of question, look, first I have to check whether the system can move or not. If the net force is 180 and the limiting friction we can say that the limiting friction for A is 20 and limiting friction for B is 60, then 180 can overcome 80 Newton force. So definitely the blocks can move. Now whenever they move, you need to check two cases. Whenever they move, that what is the minimum value of tension possible? The minimum value of tension is can be 0 and tension is not equal to 0. If tension not equal to 0, then they will move together, yes or no? If tension is not equal to 0, that means the string is taut in between them, and when the string is taut in between them, then they will move together. But what should we check for the first situation? The tension will always start from 0. So when we check that whether the tension equal to 0 case is possible for or not, that is the first condition we need to check. If something is possible at tension equal to 0, will tension rise above that? Definitely not, right? So that is why I have to first check. Look, if I draw the free body diagram of block A, then this 80 Newton force is greater than the 20 Newton force, which is the friction force. 80 Newton is greater than 20 Newton, right? So if I assume tension to be 0, first let us assume tension equal to 0. If I assume tension equal to 0, what is the acceleration of the block A?
6.
6 meter per second square. I have assumed tension to be 0. So acceleration of the block is 6 meter per second square in this particular direction. Again, if we assume that tension on this block B is 0, right? Tension on this block B is 0. Then what is the acceleration for that block? Can you tell me?
4.
It is 60 Newton. So acceleration for block B is equal to 4 meter per second square. Now you can see that with respect to B, A is coming towards it with acceleration 2 meter per second square. Yes or no? With respect to B, A is coming towards. So in that case, is it possible that tension is 0? Yes or no?
Yes.
Yes, definitely it is possible, because acceleration of A is less than acceleration of B, more than acceleration of B. So with respect to B, A is coming towards B and the string will slack in that particular case. So if tension 0 is possible, I will definitely not go for tension equal to 0 case, not equal to 0 case, right? So the answer for this question will be tension equal to 0. Right?
Yes, sir.
Can you just tell me if the same question I just replace that force by 40 Newton, what should be the answer of tension?
The tension 0 again.
Check once.
So tension 0. So again 0. So because it will come in the opposite side. When block B will come towards A.
So tension will be 0 because the blocks have same acceleration.
Check
Yes,
once.
sir.
Check once.
Yes, sir.
Same acceleration.
If the blocks will have same acceleration, will the tension be 0?
The same acceleration is.
Sir.
Yes?
No, sir, they will not have same acceleration. Sorry, I made a mistake.
Why same acceleration? No. Sir, one is having 4 and one is having 2.
Yes, sir. B is having 4 and A is having 2.
Is
Then
that
we can say that
possible?
with respect to A, B is coming towards itself.
No,
Is it possible?
that cannot be said because B pulls A along with it.
With respect to A, B is moving away.
Tension will not be there.
Tension will be greater than 0.
Yes, sir. Tension greater than 0. So with respect to A, B is moving away.
So what will be the value of tension?
So 10 Newton.
Yes, 10 Newton will be the answer. One second. Yes. Look, in this case, first let us check whether the blocks will move or not. If the net force is 140, it is definitely greater than 80 Newton, right? So the blocks will move. In this case, if the blocks will move, then again I have to check for these two cases. If tension is 0, first let us assume that tension is equal to 0. If tension is 0, what is the acceleration of the block A? Have you calculated it? What is the acceleration for block A?
2.
2 meter per second square. And if tension is 0, what is acceleration for block B? Yes?
4.
second square.
2
Four.
or 4?
4.
4 meter per second square. Yes. If tension is 0, that will be 4 meter per second square, that is 2 meter per second square. Is it possible that with respect to B, A is moving in this direction?
No, sir.
No.
Because the string is taut.
Yes, the string is taut. So with respect to B, this situation is absolutely not possible because they are tied with some string. So if it is not possible, tension cannot be 0. Can tension be 0 here? The tension will always remain taut.
Sir, can you please repeat once? I got disconnected.
Yes, I have said that. Look, the block A and block B. In the block A, if tension is 0, the acceleration of the block A will be 2 meter per second square. And in that case, the if tension is 0, acceleration for the block B is 4 meter per second square.
Newton.
Yes, tell me. Yes.
The tension 10 Newton.
Yes, good. Now,
So 10.
yes, now I have checked that tension cannot be 0 in this case, as the acceleration of A cannot be less than acceleration of B. Right? So I will now go for tension not equal to 0. If tension not equal to 0, what is the condition? They will move together or not?
Together.
Together. So what is the common acceleration for them if they are moving together? Is it 140 minus 80 divided by 20? Yes or no?
Yes, sir.
So is it 3 meter per second square? Now if I know
Yes,
the
sir.
common acceleration, I can draw the free body diagram for any one of the bodies. Let us assume that it is A. So what are the forces on A? This is 40 Newton, this is 20 Newton, and this is the tension. For the forces, it is moving with 3 meter per second square acceleration. So can I say T plus 40 minus 20 is equal to 10 into acceleration, which is 3. So what is the value of tension in that case? 10 Newton. The question says a 60 kg platform has been placed on a rough incline having inclination theta equal to 37 degree. The coefficient of friction between the platform and inclined plane is 0.5. A 40 kg man is running down on the platform so as to keep the platform stationary. What is the acceleration of the man? It is known that the man cannot manage to go beyond an acceleration 7 meter per second square. Alright. So the platform is at rest and the person is running on the platform, and the maximum value of the acceleration of the person is 7 meter per second square. It is given. We have to find the range of the acceleration. What is the acceleration of the man? That means We have to find a range of the acceleration where the maximum limit is known. So definitely we have to actually calculate the minimum acceleration of that person. This is the question, right? Minimum acceleration of the person we have to find. For that, first let us draw the free body diagram of the plank or the platform over which the person is running. What are the forces on that plank? It is 600 Newton. So if I break 600 Newton into its two components, one is along normal, another is along parallel to the inclined plane. Then what is the force along the normal? It is 600 cos 37 degree. What is 600 cos 37 degree? Cos 37 degree, is it 480 Newton? Yes or no?
Yes, sir.
600 cos 37, and what is 630 sin 37?
350.
360 Newton.
So
So that
in this case, will we consider the value of A as absolute, or we have to
yes,
add
with
G
respect to
that?
ground. No, with respect to ground. Absolute. Whenever it is mentioned acceleration, you don't have to take any other thing. It is a net acceleration. So there will be another normal reaction given by the man to that block, n prime, let us assume it, and there is a friction force that is going upward on this surface, right? Now, what is the direction of friction on this upper surface of the plank? That I have to understand, right? What is the friction between the man and the platform, right? Let us draw the free body diagram of the man. In the free body diagram of the man, can you tell me what is the type of friction that is acting in between the man and the platform?
Kinetic.
Is it kinetic
Kinetic.
friction or static friction?
Kinetic.
It is static friction.
So man is
Moving. As I have already mentioned, I think in some question. If not, then you need to understand this one. That when you walk or when you run on a floor, then
Yes,
you are
sir.
definitely
Friction
moving.
acts forward.
Then you are moving.
Okay.
Direction of
But
motion.
what type of friction is acting on your shoes?
Static.
static.
Static, right? Do you know that? You can understand this part, na?
Yes.
Have we discussed this in class? No. So let me discuss this in brief. What I was discussing, that suppose when we are moving forward, so we are moving forward, and with one foot we always fix with the ground, right? You can see that this shoe or this foot is not moving while you are moving forward by moving forward your other leg or other foot. Yes or no? You are actually moving forward your other foot, and
Yes, sir.
while this moving forward while this other foot, what is the role of this other foot that you are actually standing on ground? That foot is actually holding you so that you do not slip backward. Now the question is, why I will slip backward? Because actually while moving I am exerting a force on the ground in an inclined way. So that force has a horizontal component and that force has a vertical component. Can you imagine this situation?
Yes, sir.
So this vertical component is balanced by weight and normal reaction, but which one is going to balance that horizontal directional force? Definitely friction force,
Friction.
right? Now you can think once that while this motion, this complete process, is that friction, the point of application of the friction force, is it moving, or the point of application of friction force is always at rest?
Rest.
Once again.
It is always at rest. Friction force here actually acting as an adhesive force. It is holding your foot or shoe with the ground, right? You can assume a situation where there is no friction on the ground. Suppose you are trying to move in a very slippery icy flow. Whenever you apply a backward force, what will happen? Your shoe will slip backward, yes or no?
Yes, sir.
Because there is no sufficient friction that can hold your shoe. So when you are running or walking, the role of friction is nothing but to hold your shoe in that particular position so that you can step forward with other leg. And when the other leg hits ground, you fix that leg now, and you again move forward by moving forward the other leg that was initially at rest with respect to ground. Understood? In that way we are actually walking or running. So if there is no slipping, always friction is static one. Do you understand this part? Yes or no? Is there any doubt regarding this one?
No, sir.
So now I will understand that what are the forces on the person. Its weight is 400 Newton. So if I check the component of the weights, what are the component of the weights? Normal reaction is N prime. So what is 400 cos 37 degree? 400 cos 37 degree is 160 or not? 400, no, 400 cos 37 degrees how much?
320.
320.
400 into 4 by 5, right? So that is 320. And what is 400 sine 37 degree?
240.
240 Newton. Yes. Now you can see that if the friction force on the person will act in forward direction, will the acceleration of the person increase or decrease? In that case, can I find the minimum acceleration for that person? If the friction force is acting downward the inclined plane?
Yes, sir.
Yes. In which case I will find the minimum value of acceleration if the friction is acting downward or upward the inclined plane?
Downward.
No. If the friction is acting downward, the net force on that person
Backward.
will be downward. So the acceleration of the person will increase. But it has a maximum limit, it is given. So I do not have to find the maximum value of acceleration. I have to find the minimum value of the acceleration. In order to find the minimum value of acceleration, the friction between the person and the platform will act upward on the person. Yes or no? Is that clear, this one? Look, this type of friction is static one, so the friction can act in any direction. You have to only balance the free body diagram, right? So if the person is accelerated, suppose the person is coming downhill, and after some time he finds that he is accelerating too much. You can also imagine yourself instead of that person. That suppose you have moved up a uphill, and while coming down, you are seeing that my accelerations are going up. So what you will do in order to minimize your acceleration, now will you push the inclined plane or the surface of the inclined plane, will you push it backward or will you push that surface forward?
Forward.
Forward, right? You will push that surface forward so that the friction force will act backward direction. That will decrease your acceleration, right? So in that case, I can say that the friction on that person will be backward. So what will be the direction of friction on that platform?
Forward.
Forward, right? And this is the friction, suppose F prime, between the platform and the ground. Okay, now let us consider the free body diagram of that inclined plane, of that platform. Can I say 360 plus F is equal to F prime? Now what is the maximum value of F prime? That can I find? What is the maximum value of F prime?
240.
Yes. Is it 240? No.
Yes, sir.
What is the
So
coefficient?
400.
Yes. What is the coefficient of friction? 0.5. So maximum value is mu into n. What is the value of n? Is it 480?
No, sir.
No. N prime is 320. So n is equal to n prime plus 480. N is equal to n prime plus 480. Is it 800? Yes. So can I say that 360 plus F is less than or equal to 400? So what is the maximum value of F possible?
40.
40 Newton. So if I say that the acceleration of that person is equal to 240 minus F divided by how much is the, yes, 40 kg is the mass of that person. So what is the minimum value of that acceleration? Can I say it is 240 minus maximum
5.
value of F divided by 40? So it is 5 meter per second square. So the acceleration of that person will vary in between 5 to 7. That should be the answer of this question. Is there any doubt regarding this one?
No, sir.
Clear everyone? Alright. So I don't think there is more question left in friction. We have done all these questions. Have we done this particular question?
Yes, sir.
Yes. Now rotating reference frame. We have solved few questions in our last class. Have we solved this question?
Yes, sir.
Yes, sir.
Yes, this was also solved, I think. This question
Yes.
also we have done. Now
Yes,
let
sir,
us
done.
come to this question.
This is not.
A cylinder with radius r spins about its horizontal axis with angular speed omega. There is a small block lying on the inner surface of the cylinder. The coefficient of friction between the block and the cylinder is mu. Find the value of omega for which the block does not slip, stays at rest with respect to the cylinder. That means I have to find actually the minimum value of omega.
So
Sir,
root
what
over G by mu r.
Sir, root over G by mu or into root over mu square plus 1. Under whole root.
Yes. Yes. Okay, let me just calculate
What is the
this
meaning
one.
horizontal axis?
Yes, that we need to understand that how the disc, how the cylinder is actually rotating, right? You can see that the cylinder is actually in this type of position. This position, cylinder is rotating in this position, but this is the axis of the cylinder. This is the axis of the cylinder, right? And here is your small block. Can you imagine the cylinder is rotating in this way, right? This is the horizontal axis and this is the surface of the cylinder where you have placed a block, right? Horizontal axis means this one. This is the horizontal axis. So weight is acting downward, gravitational force is acting downward. If I try to look that situation from this point of view, then you will see that there is only a circular thing that you will see, right? And you can assume this to be the axis that is coming out of the plane, the axis of rotation. And now let us assume that the block at some instant is here. What is that position? I have assumed any position theta, right? At some instant the block is here. What are the forces acting on the block if I try to see it from a rotating reference frame? Can you tell me what are the forces that are acting on this block?
And pseudo force.
Yes. The normal reaction force will act up. In which direction the normal reaction force will act? Towards the center or out of the center?
Downward. Towards the center.
Towards the center. Good. Towards the center. Centrifugal force will act out away of the center. Any other
Yes.
force? Gravitational
weight.
force? Yes. Weight
Weight.
is there. Weight is there. So there will be two components of the weights also along this line and along this line. Right? Now you can see that the this component of the weight is balanced by normal reaction, but who is going to balance this tangential component of the weight?
Friction.
Definitely
Friction.
the friction force, right? So if I try write down the forces, this is weight mg, right? If this angle is theta, that angle is definitely theta, so that is mg cos theta This force is mg sine theta. Mg sine theta. There is another force, normal reaction, and this is m omega square r, and this is the friction force, right? So I can write from here. Now this is a simple case of free body diagram. F is equal to mg cos theta, and what is the value of f? Can I say it is less than or equal to mu into n? And what is the value of n? N is m omega square r minus mg sine theta. So my equation becomes mg cos theta less than or equal to mu into m omega square r minus mg sine theta, right? So I can write that m will get cancelled out. So omega square r, mu omega square r should be greater than or equal to g into cos theta plus mu sine theta, right? So what is the omega square r? Greater than or equal to g into cos theta plus mu sine theta and divided by mu into r. Now omega is greater than or equal to this one. Can you see that in order to find the minimum value of omega should be greater than or equal to this one, right? In order to find the minimum value of omega that satisfies all the angular position theta, right? You have to check what is the maximum value of this numerator, right? Cos theta plus mu sine theta, because omega is greater than or equal to this one. So you have to check for the maximum value of the of this part. If the omega is even greater than this one, then definitely it will satisfy all the conditions, right? We have done already that what is the maximum value of cos theta plus mu sine theta?
Root over plus mu square.
Root over of 1 plus mu square, right? So the answer for this question should be root over of g by mu r into root over of 1 plus mu square. You can do it by differentiating this one. If I differentiate it, it is minus sine theta plus mu cos theta equal to 0. So I can say that tan theta is equal to mu. If I now put the value of cos theta and sine theta in terms of mu, you will find it will be 1 plus mu square by root over of 1 plus mu square. That is nothing but root over of 1 plus mu square. That should be the answer for this question. Ask if there is any doubt. Now this question says a metal disc of radius r can rotate about the vertical axis passing through its center. The top surface of the disc is uniformly covered with dust particles. The disc is rotated with gradually increasing speed. At what value of angular speed the 75% of the top surface will become dust free? Assume the coefficient of friction between the particle and the metal is 0.5 and no interaction amongst the dust particles. Now first tell me which dust particles will first fly off the disc. The particles, they are radially,
Temporal one.
yes, they are radially away from the center or close to the center? Away from the center, right?
Sir, is the answer for this root over 10 by r? Yes, sir.
Yes.
Root over 10 by r.
Yes, good. This if you can understand this one, not a tough question again. If this is the disk, right? If this is the disk, then you can understand that if 75% of the dust particle will move away from the corner, then only 25% of the dust particle will remain, right, close to the center. Yes or no? Only 25% of the particles will remain. So 25, as they are uniformly distributed over that surface, so can I say that pi into small r square is 25% of the pi into capital R square?
Yes, sir.
Pi small r square is 1 by 4 times pi into capital R square. So small r is equal to capital R by 2, right? Capital R by 2. Now I can find that this particle, if I talk about this particle, right, if this particle also moves away from the disk, then what is the force on that particle? I can say that the force, centrifugal force on the particle is m omega square into r, right? And the maximum friction force on the particle, which I will put the limiting value, which is mu into n. Right now, n is nothing but mg. You can understand. So I can say that m omega square r is greater than mu into n. Right? Mu into n. N is equal to mg. Right? So the value of omega should be greater than or equal to root over of mu into g by r. Right? What is the value of mu? It is equal to half. So that is equal to root over of 5 by r, which is r by 2. So that is root over of 10 by r. Yes, that is the answer of this question. Again, a simple one. Have you solved this one? I have given this question in your PDF or not?
Yes, sir, given.
Yes. So have you tried to solve this one?
Tried.
Right. Alright. So this question says that a sphere of mass m is held at rest on a horizontal floor. One end of the string is fixed at point vertically above the center. Other end is connected to a small particle small m that rests on the sphere. The string makes an angle alpha with the vertical. Find the acceleration of the sphere immediately it is released. Good question indeed. We can draw the free body diagram of the sphere, and let us first draw the situation. So there is one string, suppose here, which is connected here at this point vertically above the center, right? And there is another particle here of small m mass. Sphere has in mass a capital M, and sphere rests over a smooth floor. There is no friction anywhere that it is given. So now, from this condition, can you first tell me that what should be the direction of acceleration of that sphere? Can I find what is the direction of acceleration of that sphere?
Towards right horizontal.
Towards right horizontal, definitely. So I can write that acceleration. I do not know the value of acceleration, but I can say that definitely the acceleration for that sphere should be in this forward direction. Right? Acceleration of the sphere. That is, for example, this is A of the sphere, AS. Okay? And if I draw the free body diagram of that sphere, then you can see that only force that is responsible in horizontal acceleration is nothing but the normal reaction provided by the mass m and its horizontal component. Yes or no? Can you check for
That
the
angle 90 degree.
Is it at 90 degree?
which angle?
So that
Rod and that center, from the center line.
No, it's not 90 degree. This angle is alpha. This angle is alpha. Right?
not that. Sir, between the mass, that the line connecting the center of the sphere and the mass with the rod is the 90 degree.
This angle, no, it's not 90 degree.
Okay,
This
sir.
is not a tangent, right? This is not a tangent.
It's not done.
Alright. So I can say that if this is normal, what is this angle alpha? Right? This angle is alpha. Sphere is that 90 degree. A sphere of mass m is held at rest on the horizontal floor. One end of the light string is fixed at a point vertically above the center of the sphere. The other end is connected to a particle string mixed with the vertical. Is it possible that it is Not 90 degree. It is not given, so I will not assume it to be 90 degree. Right? Can I find this angle? The lengths are also not specified. In that case, how can I find that angle?
Yes, sir. That is only the problem.
Lengths are also not specified. I think that
Sir, we cannot consider that as the tangent
yes, I think that
because it's
we have to
like
consider. Yes,
just above the sphere, so we can consider. I think we can consider it as the tangent.
this line is just
How can that is triangle?
no. That point that may be look.
Sir.
Yes, bolo bolo.
Please, can you explain the question once?
The question says this is a sphere of mass capital M, and there this is a ball of mass small m, and the ball is hanging from this point, and this ball lies at the surface of the sphere here. Right? Someone was holding that ball at this position. Now, if the person just releases that ball here, then what is the acceleration of that sphere that we need to calculate? Right? Now, the question is that whether this angle, the line joining small m and the center of that sphere with that particular line is 90 degree or not. If it is not 90 degree, I don't think we will be able to solve this question, because we will not be able to find other angles also.
Sir, it will be 90 degree because the small ball is touching the sphere at that moment, and it cannot go inside the sphere also. So that cannot be a second.
But this type of situation it is also possible. This type of situation is also possible.
Yes, sir.
Yes or no? Yes.
So, but the figure we can make it out.
Yes.
That it is 90 degree.
So we have to assume it.
Even figure we can assume.
Yes. From the figure it is understood, but again it should be mentioned in your question. So I think that the question is incomplete, but it should be mentioned. So let us assume it to be 90 degree, right? Then try to solve this question. If it is 90 degree, then what will be this angle? If this is 90 degree, this is also alpha, yes or no?
Sir, yes.
This is also alpha. So what is the horizontal force on the sphere? The horizontal force on the sphere, horizontal force on a sphere is equal to n cos alpha, and that is equal to capital M into AS. Can I write that? First equation I can write it. Right. Now let us talk about the free body diagram of that ball M. Right. The ball is hanging now from this point, and what are the forces on that ball? Can you tell me what are the forces acting on that ball? One tension is there, one weight is acting downward, another normal reaction is acting in this direction. Now I can assume the normal reaction to be perpendicular to the tension, because the tension I have assumed to be the tangential direction. Now if I release that ball from here, can you comment on the acceleration of the ball? Which direction the ball will accelerate at that particular instant?
Sir, towards the center.
Towards the center,
Towards the center of what?
the sphere.
Towards the center of the sphere. Why?
It will perform a circular motion.
It will perform a circular motion. So in circular motion, we have seen that two types of accelerations always act. One is towards the center, which
Radial
is
and tangential.
yes, radial acceleration, and one is tangential acceleration. But what will be the value of radial acceleration in this case?
So t minus mg cos alpha minus.
No, what is the value of that acceleration? Is there any radial acceleration at that instant? No, because
So it is 0.
why? What is the reason behind that?
So speed is 0.
Yes, because it is released with zero speed, and radial acceleration is v square by r. Right? So the radial acceleration is 0. So can I say that the only acceleration of that ball is along this line, which is tangential acceleration? Right? Acceleration of the particle.
Yes, sir.
And what is the value of this tangential acceleration? Can I say that if this angle is alpha, so it is mg sine alpha minus n divided by m? Yes or no?
Yes, sir.
Now we have two equations, but how many unknowns are there? As, n and ap. So what equation I can
Constant.
form? Yes, I can form an extra equation by constant relation. Can you find a constant relation for AP and AS? Do you remember the constant for the rigid bodies?
So AP cos alpha is equal to AS.
AP cos alpha equals to AS.
Yes? Is it
So
true?
AP cos alpha is equal to AS.
AP cos alpha is equal to 1.
Think again.
AS cos alpha equals to AP.
No.
Yes. What is the direction where I take the component of the accelerations? Constant equation?
Along the line joining them.
Yes.
Along.
So along this normal line I have to take the component. Right? Don't do that mistake.
AP cos alpha
Yes, sir.
is equal to AS cos alpha.
Yes?
AS cos alpha equal
Yes.
to AP.
So we can write that constant equation is AS cos alpha equal to AP. Right? So AS cos alpha, the component of sphere acceleration along the normal, is equal to AP. Now I can use these equations to find out my answer. Right? What I have to find? AS. So let me first eliminate AP. So AP is equal to AS cos alpha. So M into AS cos alpha, M into AS cos alpha equal to mg sine alpha minus n. Now the value of n is equal to M into AS by cos alpha. Right? If I take AS in one side, then the value is AS into M cos alpha plus capital M by cos alpha is equal to mg sine alpha. Right? So from there I can find the value of AS equal to mg sine alpha cos alpha divided by capital M plus m cos square alpha. Can we put the value of alpha? It is half into mg into sine 2 alpha. Sine 2 alpha is how much? Root 3 by 2. Right? Sine 2 alpha is sine 60 degree. Divided by capital M plus small m into cos square alpha. Cos square 30 degree is 3 by 4. Are we getting this one? So 4 gets cancelled out. So it is 10 root 3 m divided by 4 capital M plus 3 small. Right? I think that should be the answer of this question. Yes or no?
Yes, sir.
Yes.
Any doubt in this solution? Have I given this question also in your PDF?
Which one?
This one? Can you see my computer screen?
Yes, sir.
Yes, sir.
A block A is made to move up inclined plane of inclination theta with constant acceleration a0 as shown in figure. Bob B hanging from block A by a light inextensible string is held vertical and is also moving with the block. Calculate the magnitude of acceleration of block A relative to the bob immediately the bob is released. Alright. So can I say that the magnitude of acceleration of A with respect to B is the same as magnitude of acceleration of B with respect to A? Yes or no?
Yes.
Acceleration will have the same magnitude, only the directions will be the different. So now if I try to analyze that situation with respect to A, then what are the accelerations of B? With respect to A, you can see that B can only move in a circle, yes or no? With respect to A, B can only move in a circle. And with respect to A, what are the forces acting on B? This will be MA0, right? And with respect to A, if I assume that the acceleration of the A is only tangential direction, that is acceleration of B with respect to A. Can I write this? This is tangential of B with respect to A.
Yes, sir.
Yes. Calculate the magnitude of acceleration of block A relative to the block B.
Sir, I'm not getting what you have written.
Yes. One second. Let us not talk about the forces. I have drawn the force here. I am trying to look that situation with respect to the block A. So if I see with respect to the block A, then with respect to the block A, the the particle or the ball can only move in a circle, yes or no? First tell me this one. With respect to A, the particle can only move in a circle because now A is at rest. So this is rest, and you can see that this is a pendulum type of thing. Yes or no?
Yes.
This is a pendulum type of thing. So with respect to A, the ball should have an acceleration in this direction.
Sir, it shouldn't it be opposite? Because the pseudo forces are acting in the opposite direction.
With respect to A, yes, it may be. I only find the magnitude, so it may be, yes. Definitely it will be in opposite direction because the forces, if you see that it will be in opposite direction. You can take any direction, no problem. The magnitude you have to only find. So can I say that with respect to A, the ball B will always move along a circle, and as with respect to A, it does not have any speed. Initially, it does not have any speed because both of them were moving with the same speed, with the same acceleration earlier. And as I have released just, the question is asking about the acceleration. So with respect to A, the ball will move in a circle with only the tangential acceleration. Right? If I ask you what is with respect to ground, with respect to the ground, at this instant, as I release, with respect to ground, what is the direction of acceleration of that ball B? Can you tell me with respect to ground, what is the direction of acceleration of the ball B?
Between these two.
Yes?
So it will have an A0 and this one also.
Yes, so with respect to ground, the acceleration of B, can I say that will be a vector addition of these two?
Yes, sir. This one.
Right? But if you think about with respect to B, the free body diagram of that ball, what are the forces acting on that ball with respect to B at that instant? Is that
Sir,
only tension and weight?
pseudo force and
With respect
weight.
to ground, I'm talking with respect to ground.
Oh, tension and pseudo force.
With
So tension
respect
and
to
weight.
ground, there are only two forces acting on it, and both of them are in vertical direction. So, is it possible that with respect to ground, at this particular instant, it has some horizontal acceleration?
No.
So, can I say that the resultant of these two accelerations only along this vertical line?
Yes, sir.
Yes. So, if the resultant is only along the vertical line, then can I say that this ABA is definitely is equal to A naught cos theta? Yes, sir. It is with respect to ground. It is with respect to A. Yes. With respect to ground, the acceleration of block B is this one. So I think that is the answer of this question. Now magnitude will be the same. Either it is with respect to A or with respect to B. The acceleration will have the same magnitude.
Sir,
हाँ बोलो.
at this instant, how can we tell that the acceleration of A is also A naught?
How can we
Because
say that acceleration of A? It is given that acceleration of A is constant.
sir, but when B is released, then the A naught will change because the tension is there, and that component of tension will
Yes.
also be along A.
But who said you that the force on A is not changing? The force on A must be changes also. That is why so that the acceleration of A is constant.
So means after releasing B also, then also it will move with
Yes.
A naught only.
Definitely, you have to assume it always it is a constant by some external force. That external force may be anything. You do not know the behavior of that force.
Okay, sir.
Alright. So look, this type of questions are a bit tricky, but if you have a proper knowledge of circular motion, you can solve it. Should I give this as your homework?
Yes, sir.
Yes, sir.
Yes, take it as your homework. Take your time, no hurries. Just try to understand that question and write down the equation. I'm very much sure that you will be able to solve it, right? So just leave it for now. Try it at home. Let us move to banking of roads. Banking of roads are very common. If you move in a highway, then you should note that whenever there is a turn means there is some circular road, you will find that the road is not actually flat. If you observe very minutely, you will find that the road has some inclination with the horizontal line, right? It's very much clear in that Durgapur expressway. If you note that when you move it, there are several flyways which are actually bent in some portions. So when you look to that bent portions from far, not very close, you will not be able to understand them. Yes.
So can you repeat what you told? Actually, my net connection got
Yes,
interrupted.
what I'm saying that banking of road you will find whenever there is a turn, in and most of the cases you will find them in highways, and there is a very good example in Durgapur Expressway. If you look from far, then you will see that whenever there is a turn means a circular bend. Then you will see that the road is not actually flat or horizontal. The road is somehow bent or makes certain angle with the horizontal. That is known as banking of road. Today we will study why that inclination is needed and what will happen if there is no inclination, what is the problem. So let us first take this example of a horizontal road, a flat horizontal road, but it is a circular road. Yes, tell me.
Sir, the answer of question 53 is 6 meter per second.
Yes, good. It is 6 meter per second. The answer is 6 meter. Okay, rest of you also try them. try the question. Till now, right now you just focus on this banking of road. Okay. So I have drawn a circular road, and this is a circular horizontal road basically, right? The radius of that circular road is r, and a car is moving on that circular road with a speed v, right? The speed of the car is constant, the car is moving with a speed v. Now if I draw the free body diagram of that car, now I will move into a rotating reference frame, and you can see that the forces I have shown here, the normal reaction, the mg and the friction force, and mv square by r or m omega square as the centrifugal force. Now, if I ask you that what is the equation in that rotating reference frame, I will write that F is equal to mv square by r, but F definitely has a certain limit. So, F is less than or equal to mu into n. So, V is should be less than or equal to under root mu rg, right? You can see that in this particular case, the maximum speed of the car can be root over of mu rg, right? You can just equate this equations. Mm will get cancelled out. V square equal to r into mu g. So V is less than or equal to root over of mu rg. And if I ask you that when V is equal to mu rg, what will be the value of the friction force? Is that friction limiting in that particular case when V equal to mu rg?
Sir.
Yes.
Why is the friction inward?
Why the friction is inward? Because if the car is moving, there must be some force which is holding that car towards the center. Otherwise, the car will move away from the center. So that friction here is acting as a centripetal force.
Okay, sir.
Now, in this particular case, if I say that suppose the speed of the car, the maximum speed we have found is say 40 km per hour or 20 km per hour, right? So if you are in a turn and if you are turning in that road with a speed more than 20 km per hour, what will happen?
So it will topple.
No.
Meet outwards.
It will move away outward because friction is limited, and in that case mv square by r is greater than friction force. So what will happen if you move greater than that velocity, root over of mu rg, then the car will slide, right? The car will slide off the track. Have you understood? The car will slide off the track. And if the speed is less than root over mu rg, then it is possible that yes, the car will safely cover that bend. Safely it will move in that bend.
Can
But-
you repeat once more?
Yes, I'm saying that from this expression it is very much clear that in order to move that car safely in that bend, what should be the maximum value of the V? Under root of mu rg or not?
Yes, sir. Yes, sir.
Yes. So if V is greater than V max, then what will happen? The car will skip away. The car will skid away from the circular path
Yes, sir.
outside. So that is why I am saying that for the safe motion of that car, the V should always be less than mu rg. But again, if V is equal to mu rg, root over of mu rg, if V is equal to root over of mu rg, in that case the friction is maximum, yes or no?
Yes, sir.
If V is equal to root over of mu rg, friction is equal to maximum. If friction is maximum, what does that mean? Where the friction force is acting actually? Can you tell me where the friction force is acting? Friction force is acting in between the tire of that car and the road, right? So if the friction is maximum, then can I say that wear and tear of that car, of the tire of that car is also maximum?
Yes, sir.
Wear and tear mean the damage. The damage of the tire of that car is also maximum in that case,
Yes.
right? So that is why the road is bent or inclined so that the whenever you move, the friction force is minimum on the tire of that car, so that the wear and tear of the tire is minimum. right? We will understand how it can be done, right?
Sir,
Yes.
if the if the car is moving with a velocity slightly less than mu rg, then there will be no wear and tear because it will be rolling till then.
Why there will be no wear and tear? There will be no friction. No wear and tear means no friction.
No, sir, but the car wheel will be rolling.
No, you are not talking. We are not actually talking about rolling friction here. Okay, let me make you understand. One, one second.
Sir, the friction.
Yes. So we were discussing this, that if the car, the tire of the car, suppose, what is rolling friction? Let me just give you an idea. That when the car is moving in this direction and this is the surface, then the friction that acts between the tire and the road along this road, this is called rolling friction. That friction may be forward or backward. It is a static friction, and that has a very small value, you can say, right? This is rolling friction. And if something is rolling, actually, ideally, friction is absent. Even if there is a friction coefficient between the tire of the car and the road, when something rolls, then there is no roll of friction, there is no friction. We will talk about that in rotational motion chapter, right? But what friction I am talking about, that if this is the tire of that car, right? This is the tire of that car, and suppose the car is moving in this direction. This is the road, right? This is the road. Let me draw it first. This is the road. The car is moving along this road. Then there are two types of friction acting, may act actually. If you talk about rolling friction, as I have said, that when it is properly rolling, there is no friction. Or again, if you say that the rolling friction is there, the value is very small. In which direction rolling friction will act? Either forward or backward direction along this road. I am not talking about this friction.
Sir, the friction will be transverse to the.
I am talking about this friction.
Sidewise friction.
Yes?
Sidewise
radial.
friction.
Yes. I am talking about this friction. I am talking about this friction that is acting in between the tire and the road in this direction, right? Perpendicular to the motion of that car. Because if this friction is not sufficient, the car will fly off the road if it is a circular road. Understood? I am talking about this friction. Right? Now, let us take one condition, that in a horizontal flat road, wear and tear of the tire of the car is large. Now, can you understand why it is large? Whatever may be the velocity, the wear and tear will be there because friction will act. Whereas if the road is inclined, then damage due to friction can be minimized. How it can be done? I have just, you can see there is a picture of the banking of the road. You can see how the road is inclined at certain angle beta, right? The road is still circular. The car is moving in a radius of r, but the road is banked or inclined by certain angle. Now, what is the reason behind that? That we need to understand. Let us draw a situation, a cross-section view of that. That this is a road which is inclined at certain angle. Right? Can you imagine this road? That this is the radius of that circular path. Suppose this is the radius of that circular path, and this is the car. This is our car. Now, if I draw the free body diagram of that car with respect to the rotating reference frame, what are the forces that I can see? one component of the weight will lie along this line, one component of the weight will lie along this line, one is the normal reaction force lie along this line, one there will be one mv square by r, and
So
the
can you just explain the diagram one?
yes. What are the forces acting on this car? Can you see that this is the angle beta that I am showing here? The road here is inclined at certain angle. Can you see in this diagram?
Yes, sir.
So the same diagram I am drawing here. This is the road that is inclined at certain angle, suppose theta, or you can say beta here. Theta is equal to beta in this picture. What are the forces acting on this car? This is Vn, normal reaction. This is mg cos theta. This is mg sin theta. This is mv square by r, mv square by r. Now there is a component of mv square by r like this, mv square by r cos theta, and there is one component of mv square by r, that is mv square by r sin theta, acting normally. Right? I have not yet drawn what is the direction of friction force. So all these forces are there. Now can you see that as the car is moving, can you see that in which direction car is moving? The car is moving either inward the plane or coming out of the plane. Can you see that? Let us assume that the car is moving with velocity v going into the plane. I am only drawing a cross section of that of this road. Can you visualize that situation?
Yes, sir.
Yes. Now, if I draw the free body diagram along this inclined plane, in which direction the car can slide? Definitely along this inclined plane. But the interesting part here is that the car can move without sliding even if there is no friction between the car and the road. Can you tell me the condition for that?
Sir, then the component of normal reaction should be greater than mv square by r.
Component of normal reaction, no? Yes. If mg sin theta is equal to mv square by r cos theta, is there any role of friction to play?
No, sir.
Why?
Sir.
Because there is no tendency of motion or sliding of the car along that inclined plane. Right? So I can say that if the first situation, there may be three different cases. If mg cos theta is equal to mv square by r mg sin theta, sorry, is equal to mv square by r cos theta, then can I say that v square is equal to rg tan theta, or v is equal to root over of rg tan theta? Can I say that? This velocity is the critical velocity. It is known as critical velocity. Why it is critical velocity? In that case, friction is zero between the tire and the road, and the wear and tear is zero if you actually move in that road with this particular speed. Right? But is that only speed possible? No.
No,
Why?
sir.
Because there
More
is
than-
friction. There is friction. Now, if I assume that the speed is greater than that V critical, let us name it VC, V critical, let us name it V critical. Now, if I assume that the car moves with a velocity greater than V critical, then what will happen? What will be the motion tendency of sliding of that car? In which direction the car will have a tendency to slide? Upward. In the direction of v square by r cos theta, yes or no?
Yes, sir.
So in that case, in which direction friction will come into play?
Downward. Downward
Downward.
along the incline.
Downward, right? So if I now take the second case, that v is greater than v critical, then friction acts down the plane, right? So in that case, yes, if v is v greater than v critical, So which component will be higher, mv square by r cos theta or mg sin theta? Which component will be higher?
So mg sin theta.
Is it?
Say mv square by r cos theta.
mv square by r cos theta. By r cos theta.
mv square by r cos theta. V is greater than v critical. In v critical, mg sin theta equal to mv square by r cos theta. So if v is greater than v critical, then mg sin theta is a constant. You cannot change mg sin theta, but you are increasing v. So which part of the force will increase? mv square by r cos theta. If it has a larger magnitude than mg sin theta, then in which direction the car has a tendency to slide?
Upward direction.
As soon as it has a tendency to slide upward, will friction come into play in that case?
Yes, sir.
In which direction? Opposite direction? So in downward direction. Can I write now that the value of friction in this case can be found by mv square by r cos theta minus mg sin theta? Yes or no? And that has a maximum value of mu into n. Now n is equal to mg cos theta plus mv square by r sin theta. Can we write this equation? Just check once.
So that means we can increase the maximum speed.
Yes, but there is a limit of that. We are going to find that maximum limit now.
Yes, sir.
So what is
Sir,
that maximum limit?
Larger than the previous one case.
Yes, definitely. So I can say that v square by r into cos theta minus mu sin theta is less than or equal to mu g. Okay, g I can take common. G into mu cos theta plus sin theta. So can I get a maximum value of v in this case, which is rg into mu cos theta plus sin theta divided by cos theta minus mu sin theta under root of that? Yes or no? In a very similar case, can we calculate what is the minimum value of that velocity that is permitted? Just try to find.
Sir, it will be minus above and plus below.
In that case, v is less than v critical, or yes or no?
Yes.
So in that case, what will be the direction of friction force? Up the inclined plane, right?
Up. Yes, sir.
So just try to calculate what is the minimum value. Just try to calculate by yourself.
Sir, it will be minus above and plus below. Mu cos theta minus sin theta by cos theta plus mu sin theta.
Yes.
Yes, sir. The term means mu cos theta minus sin theta by cos theta plus mu sin theta.
Yes. So you can find that value. In that case, friction will be upward, right? So the friction force will be mg sin theta minus mv square by r cos theta, right? And that should be less than or equal to the same mu into n, mu mg cos theta plus mu mv square by r sin theta. So from there you will find the minimum value of v. So v should be greater than or equal to, you can check it, if you take v in one side, then it will be plus mu sin theta plus cos theta, and if you take g common, then it will be sin theta minus mu cos theta, right? So it will be rg into sin theta minus mu cos theta, right? Sin theta minus mu cos theta divided by mu sin theta plus cos theta plus mu sin theta, right? Now you can see that what is the purpose of that banking of road. The first purpose is to minimize the wear and tear in the tire of the road, and the second purpose is that you can have a wide range of speed with which you can actually cross that bank or that curve. Is this clear to all of us?
Yes, sir.
Just try to solve this one. The car of a mass 100 kg is moving a radius 20 meters. What informations are given? Radius is 20 meter, mass of the car is given 100, and which is banked for 10 meter per second. 10 meter per second means, can I say that V critical is equal to root over of Rg tan theta, that is equal to 10 meter per second, right? So R is 20, G is 10 into tan theta is equal to 100. So what is the value of tan theta? Is that 1 by 2?
Yes, sir.
So what
Yes,
is the
sir.
value of cos theta?
2 by root 5.
2 by root 5, right? And the
Okay.
value of sin theta is 1 by root 5. So now we can say that what is the friction force when it is moving with 5 meter per second, right? So suppose this was the road banked with certain angle theta, right? And that the car is moving with 5 meter per second. What are the forces acting along this inclined plane? One
So mg
force
sin
is,
theta mv squared by r cos theta and friction.
yes, mg sin theta force is there, mv square by r cos theta force is there, mv square by r cos theta force is there, and there is a friction, right? Now if V is less than critical one, then friction will act downward. So in the first case, friction will be mv square by r into cos theta minus mg sin theta. Yes or no? So that will be 5 into 25, 125 into 2, 250 minus 1000. mv square by r, m into v square by r into cos theta. Cos theta is 2 by root 5 minus mg sin theta. Yes. So what is this one? 10, 250. Have I done any mistake here? mg sin theta and mv square by r cos theta. mv square by r cos theta. I think it is not possible. This is coming negative, na? Yes.
So it will be mg sin theta minus mv squared by r cos theta.
No,
It should be
if
that's opposite.
okay, yes, this velocity
Less
is less
than
than.
dt.
Okay, in the first case it is less than. Yes. So if it is less than, then it will be mv square by r cos friction will be
This will
upward.
be minus.
Yes. So it will be how much? 5 into 10, 250. So it is 750. It is 250 and it is 1000. 1000 minus 250 is 750 by root 5. Have you got this one as your answer?
Yes, sir.
And in the second case, in the first case, friction is upward, right? So friction is upward. So I can say it is mg sin theta minus mv square by r cos theta. And in the second case, friction is downward. So it is mv square by r cos theta minus mg sin theta. We can calculate it. mv square by r is 100 into, now it is 15 into 15 to 25 by 20 into cos theta is 2 by root 5 minus m into g into sin theta is 1 by root 5, right? So how much it will be? 2250 minus 1000. So it is 1250 by root 5, right? So I think it is 200 50 root 5. Is this the answer we have got?
Yes, sir.
Yes. So in that way we can solve this type of questions. Banking of road, a very easy concept. If you remember that concept, I am very much sure you will be able to solve any question on this particular concept.